let's assume that we have some data and we're going to do some linear regression on it. We're going to calculate the correlation coefficient R, the coefficient of determination R squared, and all the other stuff. So I'm going to kind of do a question that has everything in it. So let's suppose we had here we have age, and here we have price. And there might be, and there will be in this case, there's going to be units attached to it, but hopefully you'll get that. So 0, 1, 2, 4, 5, 10. This is a model of car. We're looking at what price, the typical Blue Book price, if you wanted to buy this car would be, right? So you can pretend it's a Vauxhall Astra or whatever, right? Make up a name. The units that we're going to use is that the price is thousands, right? So if I write 17, it means 17,000, right? Just make it. So this particular car, brand new, so age 0, is 25,000. And if you wanted to buy a good version, right, a good working version of this car, when it's 10 years old, it will still cost you 7,000 to buy it, right? So we've got our data. So what we're going to do is we're going to answer questions such as, oops, okay, find R squared, find sigma x squared, sigma xy, sigma y squared, find those guys. And find y equals a plus bx. So I'm going to have that as my A, that's going to be my B, that's going to be my C, and then D, I'm going to use my formula to predict the price of a 6-year-old car. Right. So this would be a classic linear regression question. Quite a lot of this I think we've covered, but we've got some bits and pieces that we haven't. One bit I'm just going to skip by really quickly. Can you imagine that you did along your x-axis the age and vertically you did the price? And if you did that, and I'm making no attempt to be even vaguely accurate, can you imagine that you'd probably get a pattern that looks something like this? And what's that telling us? It's telling us as the age of the car gets older, doesn't its price decrease? So first thing is I want to find R. I want to find R squared. And how am I going to do that? Well, I'm going to use a calculator, of course, because that's really the only way we can. At least the only way we've been shown. So I'm going to hit start. And where do you think I'm going to go first? I tend to miss this step and then I have to go back and do it. Right? And then I'm going to put in my data. So in this case, the ages go in the first column. So 0, 1, 2, 4, 5, and finally 10. And then I'll zoom over to the other side and I'll put in 25, then 20, then 17, then 14, then 10, and finally 7. Now, if I've done it correctly, don't they match? See if you've got one column is slightly bigger than the other. You've probably missed somebody somewhere and you'll have to figure it out. Okay, so I've got my data in. Check. where do I go now?
Don't
Remember,
you go
we're
to calculate and 2 var stats?
well, let's find out. There's stats, right? And you're saying calculate and 2 variable stats. Now, what will we find in 2 variable stats? Will we find R and R squared, or will we find these guys?
Oh yeah, you'll find those guys.
So that'd be
Yeah.
fine, because then you could just answer this question, right? So let's just jump to that question since we're ready. Now, in my guy, you have to type in L1, comma, L2. I think in some of you, you get a modern guy, you hit enter a lot. So L1, comma, L2. And there are lots of things here, but I only want some of them. So sigma, this guy here is 22. If I scroll a little bit further, this guy here is 146. Sigma xy. Well, there's sigma y squared. I mean, they're kind of all over the place, but if I look hard enough, won't I find all of them? There we go. Can you see that I'll find all these weird sigmas, sigma x squared, sigma xy's, and so on? So that's where they were. So I got that one done. So back to now finding R and the R squared and this fella. So how am I going to get that?
I have a quick question.
Yes.
Is that 11, is that an equal sign over the
Yes,
22?
it's an equals.
Oh, okay, okay.
So how am I going to find, where am I going to find R and the R squared?
I think it's under number 8 and Lynn.
Right, so start,
yeah.
right? Start, calc again, and then we zoom to 8. Correct. So to get the R squared, and then the least squares line, they call it the least squares line. God, that's an ugly name. I like the line of beds fit, but whatever. The equation of this line. So I'm going to go and hit enter, and I'm going to put in, because I have to, L1, comma, L2, and we'll hit enter. And the R value is negative 0.93, and the R squared value is 0.87. Now, although that is a decimal, we almost always think of R squared as a percentage. How good do you think 87% fit is? Is it strong, moderate, weak? What does 87 feel like to you?
Pretty strong.
Pretty strong, you know? It's not a clear cut, you know, there's a lot of grayness in this, right? 0.7 would be moderate to me. 0.5 would be pushing it, but maybe moderate. Anything less than 0.5 is weak or nothing. I mean, if only 50% fit, doesn't that mean half the dots are pretty close to the line and the other half are miles away, right? And that's not a great fit. Whereas if an 87% fit, can you imagine 87% of the data is, the jargon is 87% of the variation is accounted for by the model, but that's just a lawyer-esque way of saying how good the fit. It'd be a pretty skinny sausage at 87, right? It would be a big honking fat sausage at 50%, right? And it would almost look like a pencil at 90%, right? So you get a kind of visualization of that. And why is that negative in R equals? Why is it negative 0.93?
Isn't because it's going down the data?
Yeah. I think there's a lot of questions where they may not phrase it that way. They phrase it kind of because they like to be awkward. As X increases, what does Y do? And the answer would be, as X increases, Y, as X increases, Y decreases, you know, which is basically saying that, right? Now, we have an equation to get. Do you see in this case, it's Y equals, the A value is 21.7 plus a V value. Well, the plus is actually a negative number, and I'm rounding it off to negative 1.7x. Now, X is the age and Y is the price. So if I was thinking of this equation, Y equals 21.7, take away 1.7x, I would think of it like this. The predicted price is 21.7, take away 1.7 times the age. And if you write the formula, this formula that way, doesn't it make it a little bit easier to understand how you're going to use it? So when it says predict the price of a 6-year-old car, really all we're going to do here is take away, well, some add-on take away. We're going to do that calculation. So I have 21.7, take away 1.7 times 6. And the answer I would get here is 11.5. And now the units kick in. Weren't the units thousands? So 11.5 doesn't mean that car will cost you $11.50. It means that that car will cost you 11,500. So you can imagine if you put 11.5 into the box instead of 11,500, right? You might not get the right answer because they want the answer in dollars. Now, if they want the answer as 11.5, that's fine. But if they want a dollar sign next to it or a real number, a real life number, it'd be 11,500. Now, that is a classic, pretty much do everything you could possibly do to a linear regression question, right? Here's your data, calculate these guys. Have you noticed in a lot of questions, they tell you this number and they just ask you to check it? That's good, because if it works, you know you've typed it in right, if you get the same numbers. And if it doesn't
And they always
work,
are right, too.
they always are right.
Yeah.
Yeah. So you can verify that every check, it's checked out correctly. Right. So, I mean, if you've got an exam question and it just said check these, I would still do that as a way of keeping track. And I think that's probably the main reason these are here. If I just said check your table, you probably look at your table and think it was fine because it looked fine the first time, right? But if these numbers don't match, then it'll force you to say, oh yeah, 62, not 26, right? Whatever. Are we cool with this? Right, now, let's turn this question on its head. Suppose I gave you that, and it was for a different car. What kind of things could I get from this question? Well, isn't 30 called the y-intercept? This is algebra. And isn't the -2 called the slope? I can actually get some useful information. For instance, in the context of this question, isn't the y-intercept the cost of the new car? Wouldn't that be how much it would cost brand new when X was 0? Remember up here, the brand new car? Now, what about this -2? That's a little bit harder to kind of interpret in English. But how about this? For every year older the car gets, it loses $2,000 in value. So in the context of this question, does that make sense? That every, if X gets another year older, you're going to knock $2,000 off the price, right? So, if it's 8,000 this year, you'll only get 6,000 next year as a trade-in, right? And 4,000 the year after that. And that's kind of as far as these guys go, right? Sometimes they just give you an equation and they ask you to pick out what these numbers are or what do they tell you, or use it. I mean, I could give you this formula and then couldn't I say to you, use it to predict the value of a 10-year-old car. Right, so this model, what would a 10-year-old be? Well, 30 take away 2 times 10 is 20. You still get 10,000 for it, right? So that would be an example of a car with very good depreciation. And by good, I mean it doesn't lose too much of its value. If you're into cars and you're buying a car as a long-term kind of thing, one of the things you might want to look in is how quickly does that car depreciate in value? Because that's very often a guide to how well it's manufactured. You know, see if a car keeps a lot of its value, it's probably a good car that lasts a long time. Yeah. See if you get one of those cars that after 5 years, nobody wants one because they're always breaking down and falling apart. You'll notice that because won't the depreciation be really quick? You'll lose a lot in a year. So I'll make this off the top of my head. Do you know if you get a Mercedes car, they depreciate really nicely, right? Even a 10-year-old Mercedes is probably still going to be worth a few, you know, if it's a good working order. We'll always assume, you know, whatever that means. But if you got, I'm trying to think of a cheap and cheerful car. Does anybody want to insult a car and say, don't get a
Kia.
Ford, whatever it is, because they, right. So who makes Kia? Is it Ford?
No, I think
You know?
it's I don't know, but it's in Korea. They make it in Korea.
Right, so something that a Korea, right, whatever, right? Don't get a Kia. 5 years from now, it'll not be worth more than a couple of thousand. 10 years from now, they're not. Some car manufacturers, don't they advertise things, and I wish I could remember, I think it's a Toyota, that 80% of all Toyota trucks are still running today. You know, that kind of advert? Well, you know, if you got a Toyota, you're probably going to get a lot of years out of it. But if you get a Kia, you might not. So that would be reflected in here. Wouldn't that number be really small and negative for a Toyota? But won't it probably be 2 or 3 times bigger for a Kia? Won't that number be how much a brand new Toyota costs and how much a brand new Kia costs? Right. So you get both of those. Are we cool with that basic question? Right. Now, yes.
For the homework, there was a part, and it said something about explained and unexplained percentages. I didn't really understand that.
Okay, it's a bit being really awkward for you. Here goes. Do you know R squared is 87%? You remember this guy here?
Mm-hmm.
Right, he's the explained one. Do you know the unexplained one? He's the other 13%.
Okay, all right.
It's just what they call it. They could have just said, tell me R squared is a percentage, right? And tell me what's left is the other percentage. And now you better be careful with that. Is it the decimal number or the percentage? Because that's the right answer, but I don't know if it's 0.87 and 0.13 or if it's 87 and 13. I guess you'll find out.
Yeah,
Is it the percent?
they ask for the R squared value as a decimal, and then they ask for explained and unexplained as percentages.
Okay, so these are going to be your 2 answers then.
Okay.
So that was a nice, easy question, right?
Yeah.
I think sometimes in this textbook, don't they make a meal of almost everything? Right? They just kind of put it in a way that makes you think that it can't be that because it's being asked and explained and unexplained.
Yeah.
I am assuming that somewhere in the textbook there's a little thing that says R squared is explained and whatever's left is called the unexplained. I did mention it once today, the official description of this is 80% of the variation is accounted for by the model. Now, they may or may not have said that somewhere, but that's the lawyer-esque way of doing it. So maybe they're just calling that explained and unexplained as a shorter version of that sentence.
Yeah, I'm not sure because I just tried it with one of the questions and it says that the R squared value as a percentage is wrong. So I don't really
Okay,
know.
which question was that? Because I have them in front of me here and I might try it.
9.2, question 5. It's
Okay.
part E.
Okay, what let's hold that thought. I'm going to go in and do question 5, or at least I'll start it, right? So give you, just so you can see what it looks like. Are we looking at the right page here? I think I've got the wrong page, don't I? Let me try that again.
That looks right.
Oh, darn it, I just left. Okay. You are looking at question 5 then, right?
Correct.
So, an economist is studying the job market in the Denver area neighborhood. Let X represent the total number of jobs in a given neighborhood, and let Y represent the number of entry-level jobs in that same neighborhood. I'm trying to remember what entry-level means. It could mean 2 things. I'm going to tell you both, and then somebody who knows will tell me which one it is. It doesn't matter for this question. It's just for me personally. Is entry-level jobs mean like you start the company at the lowest number, and then as you get experience, you work through that company? Or does it mean you work in McDonald's and you're basically just got an entry-level job, which is a job that you may stay in, or at least you get experience of, you know, working a job? Which of those two is entry level to you?
Entry level means that you have a bachelor's degree, 5 years of experience, 14 letters of recommendation, and speak 3 languages.
That's an entry level? God, that sounds like a pretty good job. Oh, but you don't have a job yet. Okay.
Yeah, also you've never worked before and you just graduated.
Oh, okay. But you know, that doesn't last forever, as my dad would have vouched. You know, eventually, I would have, if somebody had paid me money, I would have stayed in university for my entire life. I would have just took classes and everything. I might do that when I retire. I'd love to take ancient history. I think that would be a really cool class.
You can actually take it. Retirees can take it. It's for free. You don't get a degree or anything, but you can take them.
Yeah, well, I like free. That's the Scottish part. And if you can do it online, because me and my wife are probably going to do a lot of traveling when we retire, before the old bones start making it hard to move. So that's our goal. Right, back to this fella. So we got a whole load of numbers, and complete the first part, right? Draw scatter thingy, verify everybody, get all these X bars and stuff, and a picture. And then you said the guys at the bottom, the R squared didn't work?
Yeah, the R squared I put in and it as a decimal and it worked and it said it was fine, but then I put it in as explained and unexplained. Well, it might have been, let me try it again because it might want me to do it to 2 decimals.
It does.
That was
Which-
kind of tricky for me because it said, the first one, it says the 4 decimal places, and then it says to 2 decimal places. And I didn't
Right.
catch that
I
the
didn't
first
really.
time.
Right.
Yeah, I didn't
So-
catch that
yeah.
the first time. So I was like, wait,
But-
I kept getting it wrong. And I'm like, oh, that's why.
Yeah. 4 decimal places, 0.1234. 2 decimal places because it's going to be 12.34%. So they are equivalent. You know, that's maybe why it did that. Has it worked now?
Yes.
Okay.
So don't forget the decimals.
Don't forget the decimals. That's right.
I had a problem with the last part of that question. I never got it right, and I was doing the calculation. I thought I was doing it right, but I just didn't. I got it wrong 3 times.
Okay. I think let's just do this question. We got the time, right? So I'll do it from start to finish, because then if some bit didn't work for you, we're good. Now, I'm just writing down right now my data. Well, actually, I don't need to, because I can keep it here. You might not see this data, but I can still see it. So you're just going to have to trust me when I do the calculator thing, that I'm doing it with my numbers. Of course, the homework questions change the numbers on you. So you might go to this question and find out it isn't the same, right? So what you're getting from me right now is just the process. So I'm going to go into Start, I'm going to go Edit, I'm going to go up and just get rid of the old data. And then 17, this is the X value. So it's going to be 17, 30, 50, 28, another 50, and finally a 25. And then if I kick over the other side, it's a 2, a 2, a 7, a 5, a 9, and a 3, and it matches up nicely. And then I'm going to go into Stats, and I'm going to go Calc, and I'm going to do the 2 variable statistics, because they ask us to check that all those sigma x, y's and things are right. So I'm just going to do that now. So I'm going to put in L1, comma, L2. And for instance, sigma x should be 200. So if you add up all the x's, it's 200, check. Sigma y squared should be 172. And it is. So I know I've done this right because my check variables, right, all those sigma x squareds and things are all matching. So I'll now move on to the next piece of the question, which I'm not going to do, involves us plotting all those points on that little grid. Are you getting good at hitting the point and then going over to the right hand side and tweaking it if you're a number out? Okay. The next bit asks us to do all those sigma x's and sigma xy's, so I'm going to do that. And then we move on to number 8, the linear regressions. And I'm going to do L1, comma, L2. And I have an A value of negative 1.62. I have a B value of 0.19. And I better go back and change that because they want it to 4 decimal places. Remember your decimal points, I guess. There we go. They have an R value of 0.8953, and they have an R squared value of 0.8953, which becomes 89.53%. Okay. The formula is y equals a plus bx. So in this case, it's negative 1.6206 plus 0.1886x. And I think they put a funny little hat above it. And that is just for predicted y, because this formula isn't a perfect straight line, right? It's made up of lots of dots. This is just the best straight line that fits through the data. So predicted y is this. And then they give you some pictures which you can check through yourself. And I've done R squared, which is what they're calling explained. And then the unexplained is going to be the other 1047%. And then the question F, suppose X is 31. Use it to predict what Y would be. The predicted Y value is negative 0.16206 plus 0.1886 times 31. And I'm going to do that right now. So let's clear that out of the way. Negative 1.6206 add 0.1886 times 31, and I get the answer that the predicted Y value would be 4.226. Oh, and it's hundreds. So they don't want me to multiply it by 100. They just want us to call it 4.226 hundredths. So what could have gone wrong? You may have written down 422.6, because isn't 4.226 hundredths 422.6? You may have said 423, which would be the rounded off version of that answer. Does that look like what you did? Jenny, if you're asking me a question, I can't hear you. Lift it to spacebar.
How about now?
I can hear you now.
I think my problem may have been I put parentheses around the 31 rather than just put times 31. I don't know.
That wouldn't make a difference.
Okay.
It would be the same answer both ways. Did you get this number right? Is it the same value?
Yeah,
Well,
that was the weird thing is I got everything else right. So why wouldn't I have I'm just using the calculator and I couldn't figure out why it wasn't right.
Did you hit negative or subtract?
I hit negative.
Okay, it wasn't that reason then.
Yeah, it's okay.
Do it again. Just re-hit it one more time,
Yeah.
and see if you get the same number.
Okay, thank you.
Whilst you're doing that, well, I've never made a mistake, so I don't understand how anybody else could. Are you getting 4.226? Did you try it right now? Right.
I have a question on C.
Okay.
What is the X bar and Y bar? I'm guessing X
It's
bar
the
is
mean of the
mean.
x's and the mean of the
Oh,
y.
okay, okay.
And did you see in that two variable stats thing, it's there as well.
Oh, okay.
Right. I'll jump back so you can actually see what she's talking about if you haven't got the question up in front of you. Right. Do you see these guys here? They're all in that menu. That guy there is in a totally different menu. And I'm not even sure why that guy's there. Well, I get it. It would have made more sense to put that guy at E, but that's just me, right? But all of those guys are in your calculator. So's the X bar and the Y bar. And this formula, don't you have to get that in a different place as well? So they're mixing and matching what they're asking you for, but the data, the answers are in two different menus. Right? One is in two variable statistics, and the other one is in option 8, linear regression. So I guess you could go to one place and write down all the numbers that you find there, and then you go to the second place to find all the other numbers that you can't get there. Are we good? That's a pretty big standard question. Oh, they've got 4 pictures here. I don't think I mentioned this to you. Do you know that the line of best fit, the one, that's the name I like, or as they like to call it, the least squares line, right? An interesting property, do you know that that line goes through the X bar comma Y bar? So if you found just the X's and found the average and the mean, and you found the Y's and you found the mean, that would be a point in space. The best fitting line always goes through that. An interesting result. And one of these 4 guys is the right guy. If you look at this picture, it shouldn't be too hard to find out which one of these ones it is, right? Let's just look at the data. As X gets bigger, I know the data is a little bit jumbled up, but as X gets bigger, doesn't Y get bigger? You know, if you rearrange the numbers and put the X's in order, won't the Y's increase as well as the X's increase? So if I'm looking at my pictures, doesn't that mean that this one isn't going to work and that one isn't going to work, right?
We can't see your screen.
Oh,
Oh.
sassing and frassing. Can you see it now?
Yes.
Okay, so what I was saying is that if you take this data and just put the X's in order, you'll see that the Y's go up when the X's go up. So I'm looking for a line like this one here or this one here. That's why I'm not even going to pick those two, because they're pointing the wrong way, right? They're going downhill, not uphill. And then if I look at this line and I look at that line, how would I be able to tell if it's this one or that one if I gave you the equation? Well, is it my equation negative 1.62? Remember that number? Negative 1.62 plus 0.188x. Wouldn't you agree that this one has a negative as an x-intercept? So if I have the equation of a line and you give me 4 pictures, I probably should be able to tell you which one of the 4 lines it is, only from its equation. Y-intercept and the slope tells me if it's going up or down.
For the final, would you want us to graph it on our paper first and then
No,
pick it?
I
Okay.
would pick that one. And if you have time, but only once you're finished, then you might want to go back and try some things out. But that's really just for checks, you know, to make sure that you picked the right one. And if you find you picked the right one, then that's great. And if you find, oops, I picked the wrong one, then that would be working that you could show me that you knew how to get the right one and you just accidentally picked the wrong one. Okay, let me try that as an experiment. I'm not going to do a very detailed one because it would take me too long. But imagine I give you the y-hat fella, and it's 3.1 plus 2.1x, right? And I give you 4 pictures. And only one of these is going to be right, okay? I'll call that A, I'll call that B, I'll call that C, and I'll call that D. And I haven't even bothered to give you numbers. But you can still tell me which one of those is the right guy that matches this. A, B, C, or D matches this.
B?
B?
Hesitant B, but yes. Now you convince me. You're right.
Because the y, well, first the slope is positive, so it's a positive line, and then the
So,
y-intercept is at around 3.
well, it's positive.
Yeah.
And this one is negative. So it can't be this one.
Mhm.
Right. Do you see how you can use the slope of the line and the y-intercept being positive or negative to choose between 4 choices without going into too much specifics, right? You don't need to be really accurate about it. Are we good with that question? Did anyone have any other questions from that section? Because I want to move on, if I can, to the final, if we're covered. But if we're not, I certainly want to make sure there's no loose ends as well. Is there anything else from 11? So I'm going to scroll through it and maybe it'll do some things. I'm looking at this question here. Let me do something. The answers are here, and that's a big distraction. Okay, here we go. There we go. I think that's the last one we just did. Can you see question 8 is very similar to question 7? You can't see it again? Yeah, you can't see it again. You would think I would get used to doing this thing, right? But you know, the only excuse, and it's really an excuse, is you don't know how many windows I've got in front of me. And so it's quite hard for me. You've got the advantage of having probably one window, right? And it is or it isn't. And I've got this juggling act where I've got at least 5 windows and I'm trying to figure out which one to do. Have you ever heard me say, oh, I've lost you? And you wonder, what on earth is he talking about? It's because the window that's your pictures is behind some other window, and I don't know, is it behind door number 1 or behind door number 2? So I have to go and I have to minimize the windows to find you. So that's what's happening. Right. Now, the guy that we just did was actually this one, right? I think, or at least like that one. Can you see that the next question kind of takes you through the same kind of process? And the next one takes you pretty much the same question. What's the only difference? The story is different and the table of values is different, but isn't the process the same? Same kind of questions. Yeah, same thing. And last question. This is important, but it is a one-off question. So let me show you what's going on here. This table here has the X's and Y's vertical, which isn't a big deal, rather than horizontal. So here's the X's, here's the Y's. Here is what your model, your straight line predicted the answer should be. And here is the difference between them. So basically, can you imagine, let me leave this and show you, because it's very visual what's going on here. Can you imagine that you've went through that entire process, right? You've got your data, yeah, it's in a table, you found the Y guy, and it looks a bit like this. Here's my data. This is my straight line, you know, right, whatever it is. Now, if you take each one of these data points, do you notice that they're not on the line? Sometimes you get lucky and the odd 1 or 2 is on the line, but they're typically not going to be on the line. What they will be is very close to that line. Now, if I take this guy here as an example, this is the Y value that the straight line says. That's what it predicts. The solid dot is the real value. So if you take the real value and you subtract the predicted value, so in the formula that would be the Y take away the Y hat, right, that fella. What you're basically finding out is the error. Right. How close was my estimate to the real answer? Right. These errors have a name. You wish they were called errors, but their name is residual. I think it comes from the fact that when you talk about a residual, doesn't it mean the bit that's left over? You know, so the bit that's left over here is the difference between these. Now, do you notice that some of these, your answer, the real answer, is bigger than what the straight line says it? So those guys there. But in other situations, in particular these guys here, can you see that the real answer is a little bit less? So can you imagine some residuals are positive because the error is bigger than it should be, right? And some it's negative, the error is it's smaller than it should be. So what they did is they took all the X values and they plotted them against the residuals. And when you do that, you'll end up with a table or things that look like this. For some X's, it's too big, probably need one here, right? For some X's, the value is positive. For other X's, it's negative. This is what you want to see. You want a residual plot to be random. Right? Just like up and down like a yo-yo. No discernible pattern. Why is that good? It is an evidence that your model, your straight line, is a good fit. If I did a residual plot and the data looked like this, Can you see a distinct curve? That's bad news, because what that's telling me is that my straight line, my assumption that the data is a straight line is wrong. It's actually telling me that the data has a curve in it. Now, you don't normally get to see the curve, because when you do random dots, can't you make curves and straight lines go through them depending on your imagination? It's hard to tell, right? Let's try an example of that. Imagine I had some data and it looked like this. Do you all see straight lines? Okay. Do you see a curve? You still see a straight line. Do some of you see a curve? Do you see a curve now then? Can you see what one or two extra dots at crucial places, especially at the beginning or the end? Couldn't there be a curve through this there? Or could it just be a pretty good straight line with a couple of really weird guys? That's hard for us to tell. How do you know which situation it is? If the residual is random, it's a straight line. If the residuals have curves in them, it's a curve. Now, the good news is, isn't it easy to tell the difference between random and curve? I mean, doesn't random dots look just everywhere and curves look like curves? So if I take my original data and I create one of these residual plots, I can use that to decide whether or not I should have used a straight line in the first place. If my residual is random, I know I'm good. If my residual plot looks like curved, then I may be in trouble. Okay, now I'm going to go back and argue with the book, which is fine because I argue with this book a lot. They just got the same thing done. You didn't need to do any of this. So basically your job is just to pick these two things, right? When you look at this residual plot, which is this here, do you see random or do you see a curve?
Curve?
Yeah. Does some of you see random?
Yeah, I'd say random.
Right. And the book sees random and I see a curve. That's why I'm arguing with it. I think it would have been better if they gave you, I mean, it wouldn't have taken much. I mean, just give me a dot there and a dot down there. Wouldn't that have randomized that enough for everybody to say random? I think in this question, I kind of sort of see a happy face and not everybody sees it, because our brains are pattern recognition machines. That's what we do. We fill in the gaps. In fact, there's a lot of good psychology that tells us we don't actually see everything we think we're seeing. We fill in the spaces based on our previous knowledge. That's why optical illusions freak us out. You know, you can look at a drawing and it looks like it's a face sticking out, and then it looks like, you know, have you ever seen those masks that look like a face sticking out? It's still the same object, right? But as you look at it, or worse, if you rotate that damn thing, you'll get a headache. Because your brain is saying it's sticking out. No, it's sticking out. It can't be doing both. You know, make up your mind, brain, right? Is it a curve? Yes, no, it's straight. It's a curve. No, it's random, right? We're just pattern recognition. So here it goes. If the least square line provides a reasonable model for the data, the pattern of dots will seem random and unstructured. Okay. Yes, this pattern residual does not appear random. No, the pattern of residual does not. No, the pattern of residuals appear randomly. So it's asking is, in this case, for the residual plot, you choose one of them. Now, if a plot of a residual plot seems far outside the pattern, we're going to call it an outlier, aren't we? We've already talked about that. Now, what would a residual plot look like if there was a random? You won't like it. It will look like this. Wouldn't these be very small numbers because you need a scale to tell you that one? Because if you have some data and then you have an outlier, can you imagine that the straight line's going to fit most of the data, and won't it be really bad at the outlier?
Can we see your screen?
God, you lot are pushy. I used to like this class. I don't know. I think I'm going off yous. Right. You know I'm joking. So let's rewind. Random, happy face. Random, your data is linear. Great, use it, it's probably going to do a good job. Curved, patterned, I guess they called it patterned, but curved, not really that linear. I mean, it might be linear and then curve at the end, right? But it's not perfectly linear. Now, if you have a residual plot and there's an outlier, this is what the residual plot would look like. Almost all the data is going to be centered at 0 because 0 means you're bang on the line. So it's going to be really close. And this fella here is going to be high up. And that's because you might need a number like 3 because it's 3 away from it, right? That, unfortunately, makes it hard to tell if this pattern of dots is random or curved. Because couldn't you have a double whammy of you've got an outlier and the data is curved? You can't really tell randomness. So how would you redo the residual plot so you could figure out which of these two situations you really got? What would be the easiest way to fix the problem of the outlier?
Eliminate the outlier.
Right. So you go and eliminate that guy, and it looks like that. You can say, my data is linear, I've just got a one Bill Gates guy, he's screwing up the whole thing, I'll ignore him, right? And I'll use the rest of the data as my predictor. If you take out the outlier and it ends up curved, right? There's a pattern to the residuals. Won't I say, it probably wasn't a good idea that I used a straight line for this model. I should really use a different one. Now, we don't go that far, but if you want to know what the other choices are, if you look at your calculator, do you know they've got linear, which we use, quadratic, cubic, logarithmic, exponential. Those are the go-to guys in science. If it ain't linear, try quadratic, try cubic, try exponential, and try logarithmic. All they're basically doing is fitting the best happy face through the data. That would be a quadratic regression. If you want to do a logarithmic, fit the best looking log through the data. If I was collecting data about strengths of earthquakes, do you know I'd probably use a logarithmic model? You know, earthquakes are given in factors of 10. So an earthquake of level 3, if you compare it to an earthquake of level 4, do you know a level 4 earthquake is 10 times more powerful than a level 3 earthquake? It's a log. Who else uses logs? pH uses logs, don't they? So logarithmics do appear in science. Exponentials appear, don't we have exponential growth and things? That you sometimes have an exponential model. So if you were trying to model a population growth of some kind, you might use exponential regression. You just stick the word regression at the end to say the data's not a perfect fit. We're just trying to find the best shape that goes through the data. We only do straight lines, so I guess that's all we care about, right? Linear regression. That is everything I think covered. Is there anything in that last section? Is there 10 questions altogether? Yeah, that you want me to go over that you think I may have skipped by and you're not sure about?
Could you go over C one more time?
Which question C?
It doesn't matter on 5 or
Oh,
6.
Okay, let's see on 5 or 6. See which one I'm on. Here's 6. And C, find X bar, find Y bar, and find the formula. That one?
Yes.
Okay, so I'm going to go back and show you where those numbers are. Are you looking at my calculator and my whiteboard?
Yes.
Right, yeah, okay. So here goes, we're on. You go to start, you do edit, and you put in the data. So let's say we've done that. You go back to start, you go over to calc, and you choose number 2, 2 variable statistics. That one's going to have the X bar and the Y bar in it, and a whole load of other stuff that you're going to use for answers. So when I hit this, in my case, I'm going to have to tell it L1, comma, L2. So I use my second function 1, comma, second function 2. And when I hit it, I'm going to have all sorts of stuff, but X bar is right at the top, 33.33. And then if I scroll, eventually I'll get Y bar, 4.666, that one. That would be those. If I go hunting for it, I won't find Y hat. That's the equation of the linear regression line. That's because it's in a different place. So I'm going to hit start. I'm going to go to calc again, but now I have to go to option 8. And I'll put in L1, comma, L2. And the guy I would get there would be A is negative 1.6 plus nothing 0.19x. So A goes here and the B goes there. And that would be the guy they're calling Y hat, right? The predicted value of Y. And don't you get R squared and R for free in this question?
Yes.
And so what, 89.5%, not 89, 80.16% explained and 19.84% unexplained.
Gotcha.
Change the subject a little bit, but still linear regression. Have you ever heard them tell you things like, when they do, it's called, the jargon is multivariate analysis, but essentially what they do is they tell you what percentage is contributed by certain things. So life expectancy and smoking. They might say to you that 40% of your life expectancy is dependent on if you're a smoker or not. In other words, smokers, 40% of the reason they live that long is to do with how much they smoke, right? So they have like risk factors, and so you can prioritize them, right? So when we're only doing a one variable thing, when we say 80% of the data is accounted for, we're saying 80% of the reason is whatever X is, right? So 80% is to do with your, let's talk height. No, let's talk weight. Better choice. Weight. 80% of your weight is because of your height, right? 6'6" people will weigh more than 4'6" people, right? It's your height. Then 10% of it is your lifestyle. So you eat too much. And 5% is genetics, right? You got really good genes or really horrible genes. Uh-oh, joke came. Guy goes to the doctor and he says, I need to lose weight. I've tried every diet in the world. None of them work. And the doctor says, have you tried, he goes through a whole list. He said, done them all. None of them work. He says, I need to lose weight. Have you any ideas? Tell me something way out there. He says, well, I've read this newspaper article that says a good way to lose weight is that you eat whatever you like on the first day, and then you skip a day, and then you eat whatever you like on the third day, and then you skip a day. Guy says, oh, I've never tried that. Okay, I'll do it. And Comes back in 3 months and he's lost a big chunk of weight. The guy's like a beanpole. And doctor looks at him and says, wow, I said, that diet really worked, didn't it? And the guy says, oh God, I'll never try that diet again. It almost killed me. I said, what do you mean? He says, have you ever tried skipping for a day? Oh, Marie finally got it. Right. Doris, did you get that joke?
I did.
Did you get it right away, or did it take a few moments to click in?
No, I think I got it right away.
Does it qualify it's that bad, it's good, or is it just it's that bad?
No, I mean, it's good. It's good.
Okay.
I think it's pretty good.
Pretty good, okay. Can we move on now to talk about the finals? Is there anything else I need to do?
I have a quick question on your first example today.
I don't know if I can find it. I'll try. Keep going. I think it was this one. Right, okay.
Let's see. Oh yeah, there we go. In the y equals a plus bx formula, why is a 21.7 instead of 25? Because I thought a was the y value when x is 0.
It would be if this was a perfect straight line. But if you plot our data goes up and down a little bit. Okay, so we had a guy here at 25, right? But we also had some other data. Get the data accurate here. So it sounds like a contradiction. I'm going to try and explain why it's not. So this is X, the age, and this is the price, and this is Y. So if I did the data, can you imagine that one there at 0 was 25, but the other dots kind of looked something like this, right?
Mm-hmm.
If you put a straight line through this data, can you see that it is possible that the straight line, I'll have to cheat a little bit with my data points in. Can you see that the straight line might not be at the same place as the value at 0? The best
Okay.
fitting straight line might not match perfectly that one.
That's why it's predicted y?
Yes.
Okay.
Which means in this case, you're about what, 3,300 out. That would be what we'd call the residual, which is pretty big number. But since I've got so few data points, it's not a surprise. You know, you expect a lot of, expect your residuals to be quite high because it's not as accurate as it would be if I had 500 points. I'm pretty sure, I can't have no evidence, but do you know Kelly's Blue Book? You know what I'm talking about? Ever heard of Kelly's Blue Book? Right, so you know if they collect data, what they do is they basically collect lots of data on 1994, whatever the car's called, and what they sold for. And can you imagine they made a huge version of this? Can't they then go in and tell you what a particular car average price it was sold at? And that would be its standard Kelly Blue Book value. They basically just do a linear regression on it. That's how I would do it if I was Blue Book. And it's pretty easy to do because they don't actually need to go out and get the prices of cars. Don't they just need to collect them from people like car showrooms, right? What do you sell 4-year-old Ford Cortina for? What did you sell whatever? And those places are willing to share that data because by sharing that data, don't they then know what a 10-year-old Ford Cortina should be worth? So when someone comes in and wants it as a trade-in, they know what kind of number to give you. I mean, the guy shouldn't look at it and say, oh, I'll give you 500 for it. Because that's kind of hit and miss. Wouldn't he probably look up the Kelly Blue Book and say, Kelly Blue Book says it's worth 500. See, it's not me, it's not my fault. That's what your car's worth, you know, on average. That's what we'll get if we try and, sell it on, or 5,000, whatever the number would be. There are problems with models that you can't avoid, and that is that if you continue a model far enough, daft things will happen. Extrapolation and interpolation is the words. If I use my model to predict a 5-year-old car, it's totally fine. If I use my model to predict a 200-year-old car, if you plug it into this formula here, a 200-year-old car would end up having a negative value to it, right? It wouldn't be worth anything. But aren't 200-year-old cars actually worth probably more than the brand new one? So what does that tell us? It tells us that linear models should only be used in the range in which the data was collected. In this case, only use it for a 10-year window. Don't use it to predict what a 50-year-old version of that car would be worth. Because couldn't a 50-year-old version of that car probably would be worth more than, the 500 that you get for your 15-year-old car, right? If you can keep your car in good condition long enough, won't it eventually become increase in value again? Right. I'm sure a 100-year-old anything car, if it's in good working condition, is worth more today than it was when you bought it. Man, if it's a rusty old wreck and it's got one flat tire, you'll get nothing for it, right? So we're assuming that it's a well looked after model. Right, let's move on now. Definitely move on. We're good? Right. So we're going to talk about a little bit about, once I get myself sorted out here and get the right page open. Almost ready. Okay, oops, there we go. Right, get somebody in chat. Okay, Joshua's, I've answered his, thanks. And share. Right, you're looking at your class. Yes, no, maybe? Okay, good. Right, so let's start with your extra credit. I haven't talked about that, but I did promise you there would be one on Monday. And your extra credit is here. So hopefully this is visible, and if it's not, I'll make sure it is. And this is extra credit number 2. And let's see if I can do it this way. Can you see it clean, the whole thing? Are you looking at a PDF, or we'll have to go out and in again? Okay. So this one, you've got midnight tonight to get done. And there are 4 tasks. A lot of these are for me, my benefit. I want you to confirm your email address. Most people get emails from me, but some of you have told me that you're not getting things that I'm sending you. So I'm going to take whatever email you give me, and I'm going to check it against my spreadsheet, and then I'll tweak it. Maybe you're John Brown 3 and not John Brown, something like that could easily happen. Which means there's a guy called John Brown been getting a whole quarter's worth of weird emails from me, right? Now, confirm the number of class lectures you missed. So you write down how many days you've missed. I don't need to know what the dates are, but we're talking from week 1 till today, because this is the last day we were counting, right? And you're going to put 2 or 3 or 1 or none. And I'm using that. We're going to probably disagree. I have my number and you have yours. And I'm going to err on the side that I make mistakes. So if you tell me that you were missing 2 days, but I think it's missing 3, I'm just going to assume that I took a screen grab and you weren't there when I took the screen grab, right? Whatever. And that's pretty much it. So I think you should know if you lost 2 or 3 days. If you're not 100% sure, say 2 or 3 days, I can't remember, and that's fine. Actually, if they answer 2 or 3 days, it won't matter because you'll get full participation anyway, right? But might matter. Now, did you complete the extra credit Canvas class? Right, I think that's called Canvas Course 97 or something. It's got a weird name like that. Right, you will say yes or no. That will save me from having to now hunt back through a whole load of emails. If it's no, I won't bother looking for that email because it won't exist. And if it's yes, you can. Someone in my other class said, look, I took that Canvas class 2 quarters ago. Does that count? Yes, it counts. All you need to do is send me the PDF of course completion. And then in this one, you'll say yes. And that way I'll make sure that I look for it. And then you answer some questions. Now, do you see it's basically just some data on the number of fictitious hours that a student spent studying for the final exam in the last week and what they got in that exam. So I'm motivating you to study a lot. Actually, although it's made up data, in general, you do better if you study for something, right, than if you don't. So I'm pretty sure it's accurate in that sense. Now, it says find the correlation coefficient. Now, you know how to plug it into your calculator. We've kind of done that today, right? And you're going to write down R equals nothing 0.1234 or whatever it really is. And then how good a fit it is. So you're not just going to say it's a good, moderate, or weak fit. You're going to say it's a good fit, and you're going to say because look at how big R is. Or it's a bad fit, look at how small R is. Right, that kind of thing. And then you're going to write down the equation. You know, 18 plus 4.1x, you know, whatever that ends up really being. And then you're going to use it, this equation, to predict what a student who spent 9 hours studying would get. Now, I'm looking at the data, and the closest I have to 9 hours are these two, right? Agreed? So I would probably expect for 9 hours to be somewhere maybe around about 78, 77, 76. So if you don't get that kind of number, you might be a little bit worried. Right, so if you think he gets 12, you're wrong. Right? If you think he gets 140, you're wrong. I mean, for 9 hours, you should get a grade somewhere in the range of that data. Right. Agreed? Now, there are other questions I didn't ask, but if this was an exam question, suppose that this Y fella down here, right, this guy here, suppose it was 20 plus 5x, right, 20 plus 5x. Just pretend that was the answer. Wouldn't the y-intercept 20 be how much he would get if he never studied at all? And wouldn't the 5x be for every hour he studies, he would increase his grade by 5 points? So do you see how the y-intercept and the slope can actually give you some insight to how the relationship works? Okay, have we any questions about that, or are we good? This is extra credit. You can choose not to do it. It's totally up to you. But it is here. And I'll be adding the extra credit to your homework. So basically, I'll just add it to your homework grade. It's the easiest way for me to do it. So when you get your homework grade back, or when I evaluate your homework grade, you could get 102% because of that, things like that. Now, back out a little bit. Your final exam. So what you need to know to do your final exam. So that's brilliant. There's nothing there. Okay. I've just found out I forgot to do something. I can fix that. I'm going to go and show you what that would have said if I'd actually put it on. That's what you'd have seen. I'll put that on when we leave. So Our exam starts at 9, finishes at 12. Unless you've got an extended version, there'll be 2 versions. One will be just the typical one, and the other will be called extended final exam. You will know who you are if you get extended ones. So that's just where you go. You get more than, you get whatever hours you get there. There's going to be 20 questions. It's going to be comprehensive. In other words, chapter 1 is where the first stuff's going to be, and chapter 9 is where question 20 is going to be. But it's weighted more on the second half. So you're going to get like more questions from weeks 4, 5, and 6 than you did from weeks 1, 2, and 3. What else? There'll be a Zoom meeting, so I'd like you to keep the visuals on. You might want to mute everybody. I've been told that it can distract you, so if you don't want to hear other people's questions, feel free to do that. It will mean that I'll probably have to wave a lot if I have to talk to someone, but I guess you'll have to live with that. I think what I probably would do is just send you a comment text just to you if I need to find something out. What else as we continue through that then?
Is it possible to mute people while you're doing the exam? Is that what you said?
Yeah, it
Oh.
is. You just go over to your mic thing and whatever, and you click it to mute.
I think it.
You know,
Oh, I think that just mutes me.
you should be able to mute everybody, can you not?
I just turned up my volume when I took the exam last time.
Yeah, I just need
Just turn the volume to 0 then, if that's... I can mute everybody. Maybe I just have different features than you. That's possible. So yeah, if you turn the sound down, you'll not hear anybody, and that'll be the equivalent of muting then, won't it? Right. I just realised I'm going to have to fix this because it says midterm and it's the final exam, but it's the same instructions. So why don't I just tell you the instructions, as you know. That's, you don't need to see that if you can see it. That's the car that me and my wife have rented for Vegas. Me and my wife are going to Vegas on Friday morning. And we are going to set the town on fire. I'm going to get drunk and start fights. My brother-in-law is going to be with me, so he's 6'6". So I figure out if I do start fights, he can protect me. I mean, he's an ex-Marine. No, he's not an ex-Marine. Oh God, that'll start him. You're never an ex-Marine. You're always a Marine. So if you want to annoy anybody in your family that's in the Marines, just say they're an ex-Marine. That gets them going. What else am I going to do? I'm going to lose a lot of money in the casinos, because I always do. I'm going to drink lots of margaritas by the swimming pool. And eat too much and get sunburned. And I'm going to enjoy every single moment of that. That might not sound too much fun for most of you, but we have been stuck in a bloody cave for 3 months, and I am getting stir crazy. And the fact I can be out in the open and do stupid stuff just seems like a really cool thing. So, back to instructions. I've got interested, haven't I? Okay, it's the same instructions as the midterm, but we'll just go through them. Can't talk to anybody, can't send people emails, can't do, chats or anything, can't go into blog sites, can't go to tutoring sites, right? All no-nos. Can't use sophisticated software. If you don't know what I'm talking about, then you're never going to use it, so it won't be a problem. But there is software out there that can pretty much do anything you could possibly think. And you don't do anything, you just put in the numbers and it all pops out. You are and are guaranteed to have to use your TI-84 or equivalent, right? There's just tons of questions where that's not possible unless you use the calculator. So TI-84 is great, use it. Any notes you've got, PDFs, go for it. Any videos that you like watching? Yes is the answer to Joshua. Anything like that is fine. Caution, as last time, the exam will be probably, it'll take you a little bit longer. It's still within the limits. I get told in WebAssign how long it takes the typical average student to do a question. But if you have to spend a lot of time looking up videos and looking up PDFs and things, you're going to run short of time and not finish the exam. So I strongly suggest, do you know those weird and wonderful formulas that are just pains to do? There's a few of them floating about. That off the top of my head, can you remember some of the ones that you might want to do if you were doing by hand a 95% confidence interval? You know, those kind of things. You might want to do a little cheat sheet and just have all those formula in one place. It'll just make your life a lot easier than you have to hunt around for them. So I suggest you do that. Anything that you know that is something you find helpful to have in one place, you might want to do some of your time putting together some notes, like this is where you will find R, this is where you can get X bar and sigma Y, you know, anything, whatever it is, because for each person it'll be different, right? But whatever it is, you might want to spend some time having a little sheet. Okay, I need to do that start button number 2 guy 8, you know, whatever it is, you know, write it down so it makes sense to you. And that'll save you a whole load of, oh, darn it, I've forgotten where that menu is. Now I'm going to have to go and look on Canvas to find where he wrote that menu. Now I'll have to watch 10 minutes of video before we get to the bit where he does it. You know, you don't want to do that, right? So get anything that you can think of that is going to speed your job up done beforehand so that it's ready when you need it, and that'll get you moving quickly. Now, how you get the most number of points. When you're finished, you're going to do the old copy you're working by your phone, turn it into a PDF and send me, right? It's going to be just like always. Try and do as much working as possible. Because there's a lot, especially in the later sections that are pure calculator stuff, just be really careful. I mean, you know, as you're typing them in, double check each digit, whatever it is. And if it's possible, try and show me the long way of doing it, but only after you're finished. So once you've finished the exam, and now you've got 40 minutes or 20 minutes, you might go back, okay, I'm going to do that 95% confidence interval question, but I'm going to do it the long way. Right? I'm going to show them my working for it. And if you screw up there, at least the working will get you partial credit. The worst thing about the calculator is if the answer's 42 and you tell me it's 62, I ain't got anything to work with. I just have a wrong answer. So whatever you can come up with to help me give you points, you know, try and do it, right? Try and do something if you can. Some questions you can't do it in it, isn't it? It's 1 of 4 pictures, pick the picture, right? There's nothing that's going to save you with that one. So don't spend 20 minutes trying to draw your own picture. I mean, if you know it's picture 1, pick it and then move on.
So are there any graphs that we're needing to draw out? So like if there's a picture graph?
You don't need to draw them out. You might want to do, off the top of my head, there's diagrams like that kind of fall into that category are stem and leaf, box and whiskers, right? Timelines and scatter plots, right? Now, most of the time, the textbook, with the exception of stem and leaf, don't they give you 4 pictures and you pick the right one? So you might actually have a really bad picture so you know what the numbers should look like to pick the real picture. You might keep that bad picture as working. It doesn't, you know, so that I can go and look and say, she got Q3 in the wrong place, that's why she picked that picture, or whatever. Stem and leaf, they kind of give you, don't they? They just have to fill in the boxes. You know, 2, 2, 6, 1, 0, 3, and so on. You are not getting any of the construct, the weird interval histograms that guy got. I can't even remember the section. Is it 2, 1 or 2, 2 or 2 something?
Yeah.
Right. I've just given that up as a ghost. It's not worth it. So you won't get anything from that section. So that doesn't mean I couldn't give you a question where here's a histogram, what kind of shape is it? You know, skewed right? Or here is a histogram and how many people are bigger than 6 foot tall, and you just count boxes and so on. But you won't get one where you create it or you do anything like that section. I think I covered everything, but this is a good point where you ask me questions and then I say, oh yeah, I should have told you that. Anything you want to know about the final exam or anything else?
I actually have one more question about the 9.2 homework. That for 4, I had difficulty with that one.
I was going to ask the same.
Okay, what section is that again, Zoe?
The most recent one, 9.2.
Oh, that one. Do you want me to go back there and look at some more examples? Is that what you're asking?
There's a specific question that
perfect. Right, you hold that thought, and I'm going to go in, and you can tell me the specific question in a few seconds once I'm in. Okay. I closed that window off, but it doesn't take long to open it back up again. Okay, it's being very slow about loading. Here we go. What number was it? What question?
Number 4.
Okay, I'm on 4 now. Okay, I got it. I'm going to zoom over to that question, and then you can maybe tell us, you know, what the issue is, and we'll work on it. You should be looking at question. You aren't, are you? Are you looking at question 4? Didn't think so. Let's try that again. Are you looking at question 4 now? Okay, so maybe I'll just do the question and then I'll answer your question by doing it. That's probably easiest, right? The following Minitab display. Minitab's a piece of sophisticated software that you're not allowed to use, right? That's an example of it. Displays the information regarding the relationship between the body weight of a child in kilograms and the metabolic rate of the child. I have no idea what a metabolic rate is, but nursing people might, right? Is metabolic just how quickly you burn calories and things? Is it to do with that? So I'm not fat, I just have a very low metabolic rate, right? Is that how it works? Do you know I'm not fat, I'm just the wrong height? Hey, if I was 7 foot, I'd be perfect weight. Anyway, back to this one. Write the least squares equation. In this mess here, there should be a guy called coefficient, right? You see it? It says constant. So the guy that goes here is, for the constant, is 0.8408. 0.8408. And you see the guy next to it called weight? That's the fella that goes here. 0.40862. Does that question make sense? I got these answers by using this column. See the red guys that are here?
I didn't notice that until later. That's what that question I had a hard time too until I realized, oh, it's in red. That's what they want.
Yeah. Well, being in red probably did help. I never noticed that, but I thought that's because they keep changing the numbers as well, so everybody gets a different version, right? It's the book being awkward again. Once you know what it is, it's not a big deal, right? You just have to know what they're talking about. Now, for each 1 kilogram increase in weight, how much does the metabolic rate of a child increase? And use 5 decimal places. For every increase of 1 unit on the x's, doesn't the y go up by 0.40662 thingy, that day? Now, what is the value of the correlation coefficient R? Now that is sneaky. I can't see R because it's not there. In fact, the only guy that's there is R squared. Agreed? Now, you're going to have to hear me because I don't want to leave this screen. R squared is 0.966. Isn't that what it is as a decimal? If R squared is 0.966, what do I do to R squared to get R?
Square root?
Yeah, so the square root of 0.966 comes out to be 0.983 if you do it to those decimal places. Now, this could be a sneaky question. If the data is increasing, in other words, as the weight increases, the metabolic rate increases, right? Then that is a positive number. But can you imagine a different story where it's going downhill rather than uphill? If that was the case, the only difference would be negative 0.983. So I can imagine a story where you got the number and it worked question 1 or whatever it was, and then you go to the next question, you do the exact same thing and it keeps on saying error to you. And it wasn't that the number was wrong, it was the sign that was missing is what was wrong. So you have to pay attention to the context of the story because half of them go up right and half of them are going down. R squared is always positive and typically always a percentage, but can R be positive and negative depending on story? Okay. Any other questions?
I have a question on, I have to find the homework. I believe it's 8.3. It was just giving me trouble personally, so I don't know if that's something I should ask.
Yeah, you should do it. I think anything that causes one student a problem is guaranteed to cause more than one student the same problem. So, I mean, that last one we did, at least 2 of you said you had trouble with it, and there are probably 2 or 3 more who had the same trouble. Right, I'm in question 8.3. What number within 8.3?
So I'm looking right now.
Sure.
Okay, so we can do number 4.
Okay. Right, I've got it.
Part D and E, I just kept getting everything mixed up in whether I need to reject the null hypothesis, or I was just getting confused on what that meant.
Okay. So, focusing on just that part and then we'll concentrate on this question. You have a step where we do the test. That's typically the last thing you do. And you test, is the p-value less than the significance level alpha, right? And if the answer is yes, then you will reject H naught and the alternate is true. So if you say yes to the test, is p-value less than alpha, you say reject the null. If the answer is no, then you fail to reject. So let's look at this one here. So you got this question about lots of ones. So now, where is it? Down here at D? Is it here?
Yeah, D and E.
Right. Based on your answers to part A and C, will you reject or fail to reject the null hypothesis? Now, if you reject it, doesn't that mean the data is statistically significant? And if you don't reject it, then it's not statistically significant. So I guess to be able to do this question, I need to know some of the earlier answers. Do you have a p-value that I can use? If not, I'll pretend I know one just to do the question.
I have a p-value. It's not the same numbers as the ones.
That's okay. That's okay. We'll use yours. What was it?
0.0056.
Right. Now, in this question here, the significance level is 0.1. So I would be checking, is this guy less than 0.1? And the answer is yes, it is. So what does that mean? Well, it means then that we're going to reject the null hypothesis, right? And it's going to be statistically significant. So as I go through these, statistically significant, statistically significant. So it's either going to be that one or that one. And I'm going to kick out these two because that's not true, right? If you reject, right, let's wind back. If the p-value is less than alpha, you're going to reject the null hypothesis. It's going to be statistically significant. So what are we going to do about this one? At the 10% level, we reject the null hypothesis and conclude that it's significant. And that's the answer. What about this one? At the 10% level, we fail to reject. Now, do you see the only difference here is, do you reject the null or do you fail to reject the null? Okay, let's show you that as a general way of looking at it. This works for any situation that you're finishing off, right? So let's suppose that I had a different story. The significance level was 0.05. Change my pen over. I went and calculated the p-value, and it ended up being 0.0123. Then I would do my test, and I'd ask myself, is the p-value less than significance level alpha? In this case, 0.0123, is it less than this guy? Would I say yes then to this question? Agreed. And when you say yes, you will have, this is statistically significant. And to use the way they phrase it, if this is a yes, you will reject H0. Now, same story with one difference. Let's suppose that the p-value was 0.08123, right, or whatever, right? Is the p-value now less than alpha? Is 0.08113 less than this guy? Well, this guy is going to be no. And when your answer is no, you will write down, in any order you like, this is not statistically significant. And we fail to reject H0. That is a very kind of double negative way of saying something. Failing to
I think
reject
that's why
something.
I get confused.
You just have to know that that's the sentence that belongs with this story, and this is the sentence that belongs with that story. And you know there's only two stories, right? It's either a yes or it's a no.
So for the yes, we would reject the null hypothesis, say that
Correct.
it's statistically significant, and then say that there is enough evidence to support.
There's enough evidence to support H0, HA.
Okay.
You know, there's a H0, we don't, you know, that's what it used to be like, and there's an HA, this is what we're hoping to prove. If you get a statistically significant result, then you've proved what you were hoping to prove. Right, so if you were hoping to prove that the average weight of Scots people has gone up compared to what it was in the past, or if you're hoping to prove that more people like the Beatles than Queen or whatever, you got statistically significant result, you can say that that's true, you've proved it. If you get this, all you can really say is, we don't know, maybe people do like them better than the other, maybe they hate them more than the other. We just don't know anything. Not statistically significant is very uninformative. It really just means we spent a lot of time and we haven't proved anything. And this site here is much more useful because we have something that we can actually, there's a conclusion that we can say we've proved something.
And then if we were to do the either way, I think is what they call it, where it's the
Okay.
equal or doesn't equal, how
Right.
do we determine what to do with that? Like
Not a problem. You go through the same process and you will get a p-value. Remember, the p-value comes from the calculator?
Mm-hmm.
And on the calculator, isn't there a not equals to choice?
Yeah.
So that's the one you pick, and the p-value will pop up. And if this is true, you will say it's statistically significant and you will still fail to reject H0. What would that mean? It would mean there's evidence to prove that the new number is different from what the old number was. So,
Okay,
it might be a story like, we think that people today weigh different than they used to on average in the past, right? We're not committing to bigger or less than, we're just saying it's different. If this happened, you would say, yep, we have evidence now, statistically significant, that proves people today weigh different than what they weighed in the past.
Okay, so for in that instance, for it to be a yes, would the p-value have to be equal to the
It still has to be less than alpha. A yes is always
okay.
less than. So it doesn't, this is always a less than. It doesn't matter. These are the three, I'll show you the three major stories. You could, let's do a single one. Mu is 23, or mu is bigger than 23, that would be one story. Mu is 23, or mu is less than 23, that's the second story. And the third one is the mean is 23, or the mean is different, which we call not equal to 23. In every one of these cases, you still test the same way. So p-value is always to be less than the significance level. It doesn't matter if you're trying to test, is it bigger than it used to be, is it less than it used to be, or is it different than it used to be? Doesn't matter. It's the same. Is the p-value less than alpha? And that will then generate this result if the answer is yes. And it will generate this answer if you got a no.
Okay, gotcha.
Oh, go ahead, Doris.
Okay, so the greater than, not equal to, and the less than is more just you put that in to find the p-value, and then to test whether it's significant, you always see if the p-value is less.
Yes.
Okay, perfect.
Nailed it.
That's where I was going wrong.
Right. I know that these have inequality symbols, but it's still always this test, right? And the calculator figures that out, because you tell the calculator what way you want the evidence to go, right? Is there evidence to prove it's bigger? Is there evidence to prove it's less? Or is the evidence that they're different? And once you do that, the calculator is going to figure out how the p-value works in each situation. If you look at the question that we did by hand, we take that into account when we calculate the z-score. But when we do it by the calculator, we don't worry about that because that's kind of done internally inside the calculator, so you don't care about that. All you need to care about is my p-value less than alpha, regardless of the story.
Okay, thank you.
2 questions about p-value.
Yes.
First, can't it also be, can't the data also be statistically significant if the p-value is equal to alpha?
Oh. No, let's just go for less than. If you are really unlucky, will you do it to 6 decimal places so that at least you get a 0.4999 or a 0.0051? Yeah, just make it less than, don't make it equal.
Okay.
It's nitpicky, but just do that. If it is 0.5, will you do it to more decimal places to see what it really is?
Yeah, because it might be greater than
0.49998 or something, right?
Yeah.
I don't think that's happened yet, but hopefully it never will. That the p-value is exactly the wrong number.
One time it was like 0.015. Something had numbers after the
Right, well, that's enough to make
0.01
it
and
too
the
big
alpha.
then, isn't it?
Yeah.
So you're still going to say a no in that case.
Okay, and then second, when you do two-tailed tests by hand, and I know
Yes.
then you double the p-value, but
Yes.
before you double, what if, like, before you double the p-value, if it's less than alpha, before you double it, does that?
Hard luck, it's failed to reject.
Okay, okay.
And a lot of people cheat because once they see that, they go back and they pretend that they weren't looking for are they different. They were looking for it was bigger than the other guy. That way they can get their significant result. And the other way that we will never do, because it's also cheating, is that can you imagine a question where it failed on the 5% level, but it would pass on the 10% level? You know, when alpha is 5, it doesn't work. But when alpha is 10, it does. Can you see there's a big temptation, especially if you spent a lot of money and time, to pretend that it was always 10%, so you can say yes. If you're doing it honestly, you should always pick your alpha and what version of the hypothesis test you're looking for before you've even looked at the data, before you've even collected the data. And that's the honest approach. That's the honest scientific approach. So what we're doing there is we're letting the data tell the story, not adjusting the story after we've seen the data, which is a big no-no. I strongly suspect it happens more often than I'd like it to. I think politicians wouldn't even give that a second thought. Would you agree? Hey, 10%, okay, if it works for us, we'll do it, you know. What other gems have we got? Have we picked up the gem, because I've ranted on about it often enough, that you have to make sure that your data is good. So samples should be as large as you can afford. Questions should be unbiased as possible. And the people you ask should be a fair representation of whatever that population that you're interested is in, right? Those are tried and true, very important things. And then on the other side, have I given you enough situations where you can tell where people can cheat, that you can be a little bit more skeptical when you read some information that maybe it's not as clear cut as the way they are saying it? Off the top of my head, if someone tells me that they were using an alpha of 10%, wouldn't you be a little bit, you could still accept what they said, but shouldn't you be a little bit more careful, because won't that mean 1 in 10 times it's wrong? I mean, I don't want to go on holiday and find out that 1 in 10 of the countries I visit, I'm going to get the plague from. That wouldn't really be a good average. Of course, if it's, do you like Pepsi or do you like Coke? I don't think getting that question wrong 10% of the time matters a 1 iota. I'm cool with that being wrong. Do you want me to tell you a politician joke now? You ready for this? Okay. I gave you the choice to say no, so it's all your fault. This politician was in Washington, D.C. at night, and he was walking down this street and into an alleyway, and this mugger came out with a gun and pointed at him and said, "Give me all your money." And the politician looks at him all offended and said, "Don't you know who I am?" He said, "Don't you know I'm a senator? Don't you know who I am?" And the mugger says, "Okay then, you're a senator. Give me all my money." No? Okay. Who can I pick on next?
Quick
Oh, this
question.
is, yes.
So as far as studying goes, we should be concentrating more from chapter 4 and on. I mean, all
Yes.
of it we should be knowing, but
All of it, because it's happening, but more's going to happen Yeah, so that would be a good strategy, yes.
Okay. I just wanted to make sure I was doing it correctly.
Right. Okay, I got another one in my head that's got to come out while we're thinking of questions. This Polish guy was on holiday in Scotland, and he's looking for directions. So he pulls up and he stops and he asks this farmer who's in the field with his sheepdog and his sheep, trying to round him up. And they're chatting away, and Scots guy gave him directions, and then before he went, the Polish guy went and said to him, "You know, if I can tell you how many sheep you've got, can I get to keep one?" And the farmer's looking at him, and the sheep are wandering all over the place. You can't keep track of them, right? They keep moving and whatever. And he's thinking, sure, that's a deal. And the Polish guy says, "They're 834. And the farmer says, "That's amazing, you got it right. Don't know how you done that." So the farmer says, Here, pick a sheep, pick whatever animal you want." And the guy goes over and he picks one and he's taking it back to his car. And the farmer says, "Wait a minute," he says, "if I can tell which country you come from, because you never told me, I can tell which country you come from, can I get my animal back?" The Polish guy says, "Not a problem, sure." And the farmer says, "You're from Poland." And the guy says, "Yes, how did you guess? I don't even have an accent." He says, "Well, that's my sheepdog you've got in your arms." He could get to keep one of his sheep, and he takes the dog by mistake. Oh, God, Miriam, I haven't explained this one. Zoe, are you shaking your head at how bad that joke was? Is it that bad it's good, or is it just that bad again? Okay, it's a one-thumb one. Right. I think I don't want to keep you any longer than you need to be. Are we cool? Are we good? Any questions? You'll have to wait to the end to ask me or shoot me an email. Josh, hang on and we'll be good to go. Apart from that, everyone, I shall see you 9 o'clock tomorrow, and I'll get that blinking PDF with all the information that we talked about on Canvas after I've spoken to Josh. Okay, well, bye-bye. If you got a question, apart from that, you're going to have to hang around.
Thank you so much.
You are welcome. Bye-bye, guys.
Okay, can I ask a question?
Sure.
Okay, I have a question on confidence intervals. Just on your PDF, it says if independent samples are taken repeatedly from the same population,
Right.
and the confidence interval calculated for each sample, then a certain percentage of them will include the unknown population parameter.
Yes.
I was a bit confused how that works, but I feel like it makes sense.
Right. Well,
Logically,
if you do a 90% confidence interval, right, based on your sample, right, a 90% confidence interval, one way of looking at that is that 90% of the time, won't that confidence interval, somewhere in that interval, contain the real population value?
Yeah.
That's what I'm trying to say there. Maybe not clearly, but that's what I'm saying.
Okay. Okay, I just need to think about it. But
Right. Well, I mean, if you took, for instance, see if you took 100 samples from the same population and you created a confidence interval 100 times, right, based on the data you got each time. If you took those 100 of them, do you know that only 90 out of that 100 would actually contain the population mean value in it? Won't 10 of them be wrong at the 90% confidence interval?
Okay, that's how it works out.
Yeah, that's what a confidence interval is telling you, really. You're 90% confident that the right answer is in there. So you might say, well, what do I mean by 90% confident? Well, if I'd done it lots of times, 90% of the time, the right answer would be in the interval.
Okay. Oh, that's right, because the confidence interval is on a sampling distribution with all the samples.
Correct.
Okay.
And did you have another one?
I think that's it for now. Yeah.
Okay.
Thank you.
I think I'll keep Josh to the end if you don't mind, Josh. It sounds like that's probably going to work best. Moisha, you got some for me?
Yes. Okay. So I was like looking through it, and I was just trying to. So I was finishing up. I went back to finish up 8.2, and
Right.
this is gonna sound really dumb. I'm so sorry if I do.
You're not dumb. Don't even go there.
So I was doing fine up until I get to like the C part of the questions where it asks about estimating the p-value. I don't know what I'm doing wrong, but like I'm not really following as to like how I get that there exactly, because like I tried because like looking through like the 8.2 PowerPoint that you gave us,
Yeah.
just a lot of it was more like around percentages, and like the ones that were like on the homework weren't percentages, and so it's kind of like throwing me off, I guess.
All right, so we're talking, I've got 8.2 in front of me. Could you give me an example of just one of those questions, and then I'll talk you
like
through it.
5C.
Okay, let's do 5, and I'll jump to C. Okay, I know exactly where you are now. Right, so I'm going to zoom over to this window that has 5C, and we'll kind of show you the weird way in which they ask what should have been a much cleaner question. Now, you've done all the calculations already. They're in your calculator, right?
Yeah.
And you get to a p-value, right?
Mm-hmm.
And this test, the thing they're calling the test statistic is either the z-score or the t-score, depends on the question. So I'm just making up a number. Suppose it was that value, right?
Mm-hmm.
So you put the t-score or the z-score in here. Now, you also get a p-value, but the p-value in the calculator is a decimal. It's like 0.08, for example, right?
Yeah.
One of these intervals has that number in its range. So if it was 0.08, let's go through them and see which one it is. Well, 0.08 is not that guy. It's not bigger than 15. It's not between that. It's here. Wouldn't 0.08 be in that range?
Yeah.
So that's the weird way. Instead of them just having a box, p-value, and you type in nothing point nothing 8 or whatever the calculator told you it was, they give you a range of values, and it's which range is your number inside, and it can only be one of them. And that's how this works. That's just their way of doing it.
So I just basically like plug in the like from the sample test statistics and like plug it in to like the normal CDF to find the p-value and just pick the range it's in.
Right. If you're doing this as a hypothesis test, you're going to do the hypothesis test version. So you'll be doing the, what's this one? This one is a t-test, I think. Yeah. This is going to be a one sample. Yeah. This is going to be a one sample t-test that you would do. And you would get the value for t and the value for p out of that. And what I'm saying is that the p-value that you've got, I'm talking too much and not showing you. Right. Let me show you what I mean, rather than just say what I mean. That might make it clearer. I'm just zooming back to my screen here. Right. Let's pretend that we had a question like that. And so, wrong menu. I'm going to go to the place where you would type in the relevant information for this question. So I'm going to go over to tests, and I'm going to do number 2, t-test. And I'm going to use, in this question, the statistics version. And in this particular story, the mu naught, at least in my version, says 7.4. The X bar in this story was 8.6. The standard deviation in this story is 3.1. The sample size, if I scan through it somewhere or other, is 31. And I'm trying to do a story where we want to see at a 5% significant level that the drug has changed in either way. Changed in either way is the not equal to choice. So this is me going through a hypothesis test on the calculator, and now I'm going to hit calculate. And you see that there's a guy t equals 2.155. That's the guy that they're calling the test statistic. And I have a p-value of 0.039 and stuff, right?
Okay, that makes more sense.
And now I have a choice. I have to find one of 5 intervals that contains this guy. So I'm scrolling through my choices here, and 0.020. Yeah, it's this one here, which is 0.020 p-value 0.050. This guy here is in that range, so that's the one that I would choose out of the 5 choices. So I don't, here I type in what T is. I wish the book had just said, tell me who P is, and I type that in. But instead they give me a whole range of guys, and I pick the one.
Okay, yeah, because I was gonna say it like
That
threw
has
me off, and I just did not understand like the way it was phrasing it, and yeah.
I know you're good.
Thank you. I'll see you tomorrow.
See you tomorrow. Okay, Rachel, you got a question for us?
Yes. My notes aren't making much sense to me, but that last question kind of answered what I needed. But it was like 8.3 and 8.5. So for example, for like 8.3, it's finding population proportion, and it's just like using the calculator. Like my notes are just kind of all over the place, which is my fault.
Okay.
So in order to find, like, say the p-value for population proportion,
Yeah.
I would do that test, and then would I choose from depending on if there's sigma or not? Or
no, right, let's rewind. If you're doing a proportion question, there will never be a sigma. It just doesn't make sense. You won't see it. So if you're doing a proportion test, it's a lot easier because you don't have many choices. Right. There are only 2 types of proportion tests that you're going to see. One is going to be a simple proportion, where each naught is equal to some number, or its alternative is that it's bigger than, less than, or whatever, right? One of those.
Okay.
When it's that story, you will hit Start button, you will go over to Test, and you will do choice number 5, one proportion z-test. That's the only guy you'll use for proportions when there's only one sample going on. And then you'll put in the 0.31. And then let's just pretend in this story that they got 200 people and 65 of them said yes. So 65 people out of 200 said, yeah, I like Pepsi, or whatever the story is. And the one that I've got here, it's a less than story, so I'm picking the middle one. And then I just go to calculate, and all the numbers I need are there. Can you see the p-value in this case is 0.67? That's a horrible number, but that's what it is.
Yes. Awesome. And then if it has more than one,
then you
will it
almost
do
do the same, but you go to the 2 proportion.
Okay.
And you put in, I'm making this up, 45 Scotsmen out of 200 have been to France, and 55 Germans out of 300 have also been to France. What's the chances that they're different from each other, which would be that one? I've just set up basically, is P1 different from P2? And P1 was Scottish people going to France in my pretend story, and P2 was German people going to France on holiday. Now, when I hit the calc here, can you see the Z score is 1.14? That'll be the test statistic that they're asking for. And then you'll have a whole load of intervals, one of which will have 0.25 in it. And I think it's probably this one up here when it's greater than 0.25, because 0.253 is bigger than 0.25.
Awesome.
In both those examples that I've done, the p-value is so big that it's not statistically significant, and therefore you fail to reject H0.
Okay, thank you so much. You answered my question.
You are welcome.
Awesome. Take care. See you tomorrow.
See you tomorrow. Okay, almost. Right, we're good, Josh. What do you want to tell me or ask me? You better hit spacebar. I can't hear you, Josh.